Okay, let's look at some more exponential equations. So let's say I have 2 times 3 to the x plus 3 to the x equals 243. Well, we're going to learn a new method here. Now, if I see something funny that I see throughout the equation, lots of the times it's very helpful to choose a letter to equal the thing. Now I can simply take that and I can substitute what I've made into the equation. So I've made 3 to the xm, therefore I'm going to substitute m in everywhere I see 3 to the x. On the left-hand side, 2m plus m is 3m, and I can simply divide both sides by 3, and m is equal to 81. Now, because I made 3 to the xm, I need to take 3 to the x, and I need to put it back in for m. So 3 to the x equals 81. Now, on the right-hand side, I'm going to perform change of base. Notice we just have to remember all of the rules that we've learned before and apply them anywhere necessary. So I have the same base. I can simply make my exponents equal to each other. Now again, as you can see in the notes, I've checked my answer. I've taken my x value and I've put it back in for x to make sure that the equation works, but I'm going to let you do that on your own or read through the notes. Let's take a look at another example. So let's take 7 to the x plus 7 to the x plus 1 equals 392. Well, we learned from 7.1, separating exponents, if I have 7 to the x plus 1, that is simply equal to 7 to the x times 7. So I'm going to replace 7 to the x plus 1 with 7 to the x times 7 to the 1. Again, we need to be very comfortable with all the rules so we can just do it. Now in the future, I'm not going to be doing this stuff off to the right as much. I'm just going to do it and tell you to practice 7.1. Now I see a funny looking thing, and that's 7 to the x, so I'm going to make m 7 to the x. I choose m because it doesn't look like numbers. Choose any letter you like. Then I can replace 7 to the x with m, and we all know that m7 is just 7m, but I don't care. So what is 7m plus m? Well, we know that 7m plus m is 8m, and that is still equal to 392, and I can simply divide both sides by 8, and m will give me 49. Now I made m 7x, so I need to put 7x back in for m. So 7 to the x is equal to 49. Now 49 is simply 7 squared, and if I have the same base, I can make the exponents equal to each other. Again, feel free to check your answer. Let's take a look at a couple more complicated questions. So I have 2 to the x squared minus 12 times 2 to the x plus 32 equals 0. Now, if these questions have a squared, we're probably going to want it equal to 0 because it's a quadratic. So now I am going to let m equal 2 to the x. So m equals 2 to the x. Now I'm going to replace 2 to the x with m wherever I see it. So m squared minus 12m plus 32 equals 0. I can now factor it. So two numbers that multiply to get 32 and add to get negative 12 are going to be 8 and 4, both negative. Now I'm going to slowly show less and less steps. When I solve this set of brackets, I get m equals 8, and when I solve this set of brackets, I get m equals 4. Now I can take what I've made for m and I can put it back in for m, so I get 2 to the x equals 8, and 2 to the x equals 4. So I can perform change of base. 8 is 2 cubed, and 4 is 2 squared, and then I can simply make my exponents equal to each other. And again, feel free to check your answer. We'll figure that stuff out in your notes, try it on your own, etc. So let's take a look at another example. 9 to the 2x minus 2 times 9 to the x minus 3 equals 0. Now, this one looks a little bit different, so I can clearly see that I have a 9 to the x. Excuse me, 9 to the x. I can clearly see that I have a 9 to the x. So I need to make that m, but I need to work on this over here first. So I know from 7.1 that this is simply 9 to the x squared. Let's work on that off to the right. That may be difficult. 9 to the 2x is 9 to the what multiplies to get 2x. 9 squared to the x. Now I know that I can switch the x and the 2 because I'm looking for a squared term, and then I can bring that in. So I can copy the rest down. Then I can make 9 to the x equal to m, and m squared minus 2m minus 3 equals 0. Then I can simply factor, and two numbers that multiply to get negative 3 are 3 and 1. To add to get negative 2, the 3 needs to be negative and the 1 needs to be positive. Solving this equation gives m equal 3 and m equal to negative 1. Then, if I substitute 9 to the x back in, now the equation on the left is a little bit more difficult. 9 is 3 squared. I can multiply my exponents together. Now 3 is an exponent of 1. I can make my exponents equal to each other. And then I can simply divide both sides by 2. Now 9 to the x equals negative 1. There is no value that I can substitute for x that will give me a negative value. If I substitute positive numbers, I get 9 squared equals 81, etc. 9 to the 1 is 9, 9 to the 0 is 1, and 9 to a fraction, like 9 to the 1/2, is 3. This will never work. We cannot have an exponential function equaling a negative number, so no solution. Then if you test the 1/2 back into the original, as you can see in the notes, you'll see that it is correct. Okay, let's look at some more complicated exponent equations. 4 to the x minus 4 to the x minus 1 minus 24 equals 0. So I have a 4 to the x, and I like that. And I think I'm going to use it. Now 4 to the exponent x minus 1 from grade 9 exponent laws is equal to 4 to the x over 4 to the 1. Remember, we went back and forth subtracting exponents and separating exponents in 7.1. We have to be very comfortable with these methods. So I can simply say 4 to the x minus 4 to the x over 4 to the 1 minus 24 equals 0. Now my funny looking thing is the 4 to the x, so I'm going to make 4 to the x equal m. Then I'm going to replace 4 to the x with m. Now, I have a 4 on the bottom. I would prefer to times both sides by 4. So I'm going to say times 4, times 4, times 4, times 4. If you want to be lazy and put brackets around the whole thing and say times 4, feel free. But I seem to forget sometimes. So 4 times m is 4m minus. Now I only timed this one by 4 just to get rid of the 4s. Now 24 times 4 is 96 equals 0. Now 4m minus m is 3m, and if I add 96 to both sides, then I can divide both sides by 3, and m will equal 32. Now I need to take what I put in for m, so 4 to the x is equal to 32, 32, and I know that 32 is 2 to the 5, and I know that 4 is 2 squared to the x, so I can simply multiply my exponents together, and I can make my exponents equal to each other. Therefore, x is equal to, if I divide both sides by 2, 5/2. So again, feel free to take that answer 5/2 and plug it back in and make sure it all works. It has to work. So, okay, let's take a look at another similar example. 4 to the x plus 4 to the 1 minus x equals 5. So the funny looking thing will be 4 to the x. Now I need to work on this thing over here, 4 to the 1 minus x, which is just simply 4 to the 1 over 4 to the x. Again, being able to go back and forth between these two things without any problem. Go back and practice, make up your own questions, etc. So I simply have 4 to the x plus 4 to the 1 over 4 to the x equals 5. Now my funny looking thing is 4 to the x, so I'm going to make m equal to 4 to the x. And then I'm simply going to replace m in for 4 to the x. So m plus 4 over m equals 5. Now we saw in the last question, if we wanted to get rid of a denominator, we times both sides. So I'm going to times both sides by m. So m times m is m squared. I times the middle term by m just to get rid of it. And 5 times m is 5m. Now I can rearrange it by subtracting 5m from both sides. Then I can factor the equation. What are two numbers that multiply to get 4 and add to get 5? Those are 4 and 1, and they both have to be negative. Therefore, m is equal to 4, and m is equal to 1. So now I can simply take what I made for m and replace it back in. So I have 4 to the x equals 4, and 4 to the x equals 1. Notice I don't work on something until I'm done doing the process, substituting m back in, now solving. So 4 to the x, if I don't see an exponent, I give it an exponent of 1. So I simply have 4, I can simply have the same base where I'm going to make my exponents equal to each other. Now, 4 to the x is equal to, well, 1. 1 is something. Well, 1 is simply just equal to 4 to the 0. Again, we're going to use these rules interchangeably all the time. We need to be comfortable using them. So x is equal to 0 and x is equal to 1. Again, feel free to substitute back into the original to make sure it is correct.